All right, so let's wrap up and make sense of our lab that we did today. So I'm guessing a lot of you predicted, and as this is how I would have predicted in high school, is that if you have this really large, massive linebacker hitting a tiny towel boy wide receiver, the towel boy would experience a way bigger force. But what we see is that's not the case. All right, in all of our experiments, all right, no matter if how the velocities, how the mass is different in the collision, even if an object was still, the forces are opposite in direction, but they are equal. All right, scenario 1 equal, scenario 2 equal, scenario 3 equal. It doesn't matter what the objects are doing, the forces are always going to be equal. And so this leads us to Newton's third law. So what I'd like you guys to do is make sure that you guys have your target sheets out. I don't even have mine out right now. And let's flip it to the second page. So it's going to be this section right here. Right here where we're going to be following along. Okay. So Newton's third law is, right, and we know from the results of our experiment that every force has an equal and opposite force. All right, so every force is an interaction between two objects, and that force is always going to be equal and opposite between those two forces. Another demo that I like doing in class is we have those scales in class. One person just stands still, the other person pulls, and they're both going to read the exact same reading. It doesn't matter that this person looks like they're doing all the work. All right, the force between them is still going to be the same. All right, so there's a difference between seeing those results and being like, okay, yeah, they're always equal, and then buying into it. Right? Because it still does not make sense in many ways, I'm guessing, to a lot of you. Like, if we look at this replay again,
with their towel boy and wide receiver.
Like, in terms of who's in more pain, it's this guy right here, right? It's the towel boy compared to the linebacker. So how could their forces be the same? Right? Well, it turns out what causes that pain is actually not the force, it's the acceleration, how the person changes their velocity as a result of that force. And so those are going to be different because the masses are different. So let's draw out what that looks like. All right, I'm going to go back to our target sheet notes. All right. And before we get to that, in order to set this up in terms of why they have different accelerations, why the towel boy experiences way more pain, is we need to kind of set up our force pair interactions. So what I mean by that is every force, all right, has an equal and opposite force. So they come in pairs. So a way we could model this out is we could look at our linebacker, and when they hit each other, we have a force on the safety. It says safety, another position in football, force on the linebacker by the towel boy. All right. And there's also a force on the towel boy by the linebacker or the safety. We know that those are equal. All right. We also know that there's a force on, like there is a force, the linebacker does experience a force because he does slow down even just a little bit when he hits the towel boy. All right. So we know that those are equal from our results. All right. That's why I put my force here, just boxed in. Those are equal. And we're going to use this our equation as our model. All right. But how do their masses compare? The linebacker has a way bigger mass. The towel boy, all right, has a smaller mass. So in order for them to have the same force, this linebacker has to have a smaller acceleration. All right, that makes sense. This linebacker slowed down, but not nearly as much as the towel boy changed his velocity. Now the towel boy has a way smaller mass, but in order for those forces to be the same, he had to accelerate way more. So that's why we see him go flying, right? That's the pain that he experienced. It's not the force, it's the result of the force. The acceleration is where that kind of pain factor comes in. All right, so hopefully this video helps kind of wrap up, get down the main goal of our lab, Newton's third law, every force is an equal and opposite force, and also explain, even though forces are always equal when they're interacting, how you could have differences in acceleration because the masses are different.